Okay, cool. So just, okay, yeah, the recording has started. Awesome. So welcome everyone to another lecture for Rolling Scope School. Today we're going to be learning some asynchronous stuff. Kind of a different topic than compared to the one that you see on the screen, because asynchronous stuff for the front-end development in JavaScript community is all about Ajax. So that's what we're going to be covering today. So maybe you've heard about Ajax, but maybe not. So what is Ajax? Is it some fancy word that we see somewhere in the magazine, maybe in the shop? It's actually a pretty straightforward definition of asynchronous JavaScript and XML format. Remember in the previous lecture we mentioned that not everything that we do in the web is done with a beautiful object notation. It could be XML. That's what the XML stands for. So Ajax is a way for us to basically make requests somewhere for additional information from our websites without actually reloading the page. So back in the days, we had to reload the whole page to get something new from the server, because every time we did something in the web, we had to go for the HTML, CSS, JavaScript, etc. And then the communication stops, and a person, the user, sees something on the screen. So that was how we did everything back in the days. But the idea was to receive everything once, for example, the whole page. And then if we need stuff, or a user, for example, sends us some stuff, we don't need to reload and get everything again. We just need to make a small thing as a request. So kind of a history of engineering here. And again, that's how the asynchronous JavaScript and XML was born, short for Ajax. So again, in other words, this technology enables you to execute the server-side methods, basically make requests for something to be done on the server without actually refreshing the page. It could be get some data, it could be send some data, update the table, anything like that. A bit of a technical thing for you. So in classic web application, as I told you, we had to do like interactions. So that's what we call the reload process of the page. So the user browses the website, he does something, she does something, and then we had to reload to actually send the data alongside with the request for the next page. And this is how nowadays everything works. So the client, the user, just browses the page, and somewhere in the background we're doing all those requests. And this is possible again using the Ajax. So the way we do the Ajax requests is by utilizing a special object in the JavaScript itself. So as we know, JavaScript is everything is an object. So basically, people who invented Ajax, they added a special kind of built-in object to the JavaScript itself. It has been adopted by all the browsers at the moment. I think it was like maybe 5 years ago already that we adopted the whole thing. And this object just contains everything that is needed for us to make all stuff, the requests, either in the object notation or XML notation. That's why it's called XML HTTP requests. And we're basically doing the communication using one of those protocols that we discussed previously. And this is actually HTTP. So That object handles the request as it states in the name, and also it predefines some of the content type. It works usually within the responses. So plain XML, JSON, and JavaScript are supported. That object contains several methods that could be used to do that, to do the requests, like status. We discussed it yesterday. Some additional information. It has some the actual response body, if I say so. So it either text or XML, has some status that goes along with the status standardized HTTP status that tells some additional information. That object also, apart from containing some properties, contains methods that could be used to either start the communication, that handshake thing, or send the data, maybe abort the communication when it's started already, maybe add to the request, to the open request, some additional headers, etc., etc. So lots of useful stuff, and that's all inside of a special object that was added to JavaScript to help us make those requests, Ajax requests. And this is how it looks in the old-fashioned way, I'd say. We'll look into a more modern example that utilizes that object. This is how it looks. The code for me currently looks a bit off because we're doing basically one thing, like making a request, by setting in this awkward way a bunch of properties and then making some additional calls, and somewhere along the line, somewhere between those open and send, and maybe after that even, we're gonna get some of the fields inside the request updated, and we need to do lots of manual stuff to actually listen to a simple thing as a request. So that's a bit of a cumbersome thing. Like that, an example of setting up the headers. And some of the libraries that were around back in the days, they were trying to simplify the whole process, because the technology is actually good. So that's the idea behind the technology, at least. But the implementation that was around back in the days with this object, SML, HTTP object, is a bit off, as I already said, and the jQuery just tried to actually solve this problem by giving us the opportunity to pass some of the configs and simplify the whole process. And for example, as you can see in the typical jQuery Ajax method, it just receives an object as a parameter that sets lots of different properties, but behind the scenes it does everything the same as we did manually. But at least we don't do it manually. That's a good thing. And the jQuery itself, as a library, as a very well-known library, provides a lot of chaining capabilities, useful methods that allows us to work with that object. As I said, before we need to do everything manually, but now, as you can see, we can utilize some of the methods. But the basic principle remains the same. Yeah. So, before we continue, I'd like to show you some of the examples of how to organize a typical request using XML and HTTP and jQuery. Sorry. So here I have a not that complicated website built with like quickly with lots of different technologies. Uses lots of different stuff, even polyfilling the fetch. But we're interested mostly in the scripts too, like scripts with a great name, I'd say. Without further ado, without actually implementing the whole logic, I just pasted this script into that small website, static page, to demonstrate the topic. So let's take a look at the actual website. So that's how it looks. And the idea was to go to some kind of server and retrieve the current web weather information for the London. So if I were to Google London and look for the weather, hopefully we'll get the same thing. Yeah. So it is live. At this point, believe me, it is live. So that's exactly how we were to work with the whole thing. So we know now that to enable some kind of communication with a backend, any backend, open or maybe proprietary backend, we need to use that XML HTTP object, so that our website contains everything it needs down to like static information, except for the small p that is actually going and retrieving that information from the web. So to prove that I'm actually going and making a request, that XML HTTP requests, I reloaded the page, and as you can see, I'm going to the Open Weather app, retrieving some information in the preview, getting back lots of different stuff, and then passing some of the weather stuff, so clouds, maybe the temperature, if I remember correctly, the main temperature, and then even converting that temperature to the Celsius degrees. And apart from that, you know already that we're like working in the web, so we're probably using HTTP protocol. I'm getting a bunch of stuff, static stuff. So this is the page. Let's have a look. Okay, I don't see how it looks, unfortunately, but we're getting a bunch of stuff, and then at some point we're making that request, even not receiving everything at once, but still we're receiving some of the data, and then we render. So hopefully, if I just try to make the whole thing offline. Okay, now let me get the slow 3G. You will see that at some point it's blank. I'm receiving, yeah, and then after some time I do receive some of the data. And typically that's how Ajax works. So in our code example, we'll have the same website 3 or in my case 4 times for the Angular and React, doing the same thing but using different kind of technologies. So let's take a look at the actual script. So here we are, and this script is added as the last one to actually make that request happen. So if you take a look at the script, apart from actually doing some UI stuff, UI updates, which we're not interested in the moment, we are calling a make request function after setting up some variables. We're calling that function, which does something with HTTP request object. And this is the object that we are getting from the built-in object, and the VS Code even tells us some of the information that we already discussed. So as you can see, where I make the object and where I actually use, it's a whole different place. So I'm creating an object, and then I do some of the stuff, some response methods, so that I can actually update the UI once the whole thing is ready. So I'm hooking up the reaction to the request being successfully made. And then I actually opening the connection, so the handshake with the correct URL, etc., and then sending the requests. That successfully sends everything that I specified, and then when it's done, somewhere under the hood, inside this object, the ready state will be triggered and my function will be triggered. So as you can see, three main things should be done to set up a typical GET request, which is what should happen after we get the data, where should we get the data, and when should we start or attempt getting the data. And then in the response object, you can see we accessing the same HTTP request object to get some of the ready states, some of the statuses, which is 200 HTTP status, to actually update the UI. So if I were to maybe make make an error and go back to the website, it does the reloading, and then hopefully we'll see some of the error displayed. No, it's not displaying at all because that's how the logic I set up is. So invalid API key because I did a typo in the URL itself. So the request was successfully performed, but the response contained the error that I'm not authorized. So, and by looking at the error, I immediately know that either my temporary API key is wrong or the place where I'm passing it is wrong. So this is how the communication works, and by the message itself that was sent by the Open Weather API, I can tell exactly where to look in my code. And yeah, my UI was updated accordingly. I didn't break anything. I still have an ability to scroll, do some reading if I'm interested in, but I don't get that live data. And no matter how much I refresh, no matter where I go on the page, it's not broken or anything. It's just not working. A small, simple Ajax request. And that's all handled in this response methods. So that was XML HTTP. And since we discussed the jQuery variant of the same code, let's look at the example there. So I'm going to do a live server that contains the same thing, but now I'm not constructing that object myself. I'm actually letting the jQuery do the work for me, and as you can see, the request is being sent and I see the data. And it's kind of live data, so kind of a cool way to add the dynamics or dynamic content to your website. So yeah, go and look at the jQuery example. So compared to cumbersome XML HTTP request object, the jQuery code looks much simpler. So I'm using the jQuery. I'm specifying that I want to get something for this URL with this API key. And then when you're done, update the UI with success or update it with an error. So an update with an error is actually hiding that thing. So again, if I do the error thing, it just immediately hides the whole thing. So comparing it 1-to-1, as you can see, this code actually looks a bit old to me, because I need to do a bit of extra work of specifying what should happen, when to open the request, the connection, and when to send it, what should happen in one of the cases and then in the other. Everything looks awfully cumbersome, but with the jQuery help, I'm able to do the whole thing and with ease and just specify the success and an error states. So, and that's kind of simplifies the whole Ajax thing. So whenever you do any requests, you're actually working with two different path, I'd say. the error path where everything went wrong and you should somehow let the user know that something went wrong, or a success path. And that's pretty much what you're going to do every time you do the async with Ajax technology. So that's how most of the libraries do, even the advanced ones like Angular or React. So yeah, we also have the fetch, but we'll talk about it a bit later. At the moment, let's go back to presentation and talk about some of the key things that you're probably going to encounter during your development. So let me just suppose port go live again into not the Angular one, but into jQuery one, yeah, so that we can see some of the stuff that we're going to be talking about at the moment. And yeah, headers. If you look closely at the request and response headers, so by headers we mean those configurational stuff that we or the server sends to a partner, so to the other side, either client or server, to specify some additional information. And in those headers, we see the connection keep alive that we discussed already, but also we see some of the strange, not that familiar headers that the server specifies. For example, this control allow origins. So it somehow allows the origin, which doesn't make it much sense. It allows the methods. It says, so basically what it says or what it implies is that, hey, you made the request and I don't recognize you, but I don't really care what the origin of the request was. And since you use one of the allowed methods, you can go. Here is the information. So it implies that if I do the request with a different method, or maybe here was some kind of a unfamiliar domain, and I was not that, apart from that familiar domain to the server, it would not reply to me, or at least reply, but the browser itself would somehow use this headers, these configurations to actually block me from seeing stuff or receiving stuff. And that's actually how it works under the hood with the same origin policy and cross-origin resource sharing policy. So same origin policy. Basically what it states is that by default, back in the days, we were allowed to do anything. We're not like rejecting requests. We're not like preventing something in the web from happening. And for some time, it worked fine. But at some point, some of the malicious users of the internet discovered that they can somehow treat other people's code to do some weird stuff. So we're talking about fraudulent scripts, cross-site scripting, etc., etc. So bad things. And the internet community just came up with a policy that kind of describes the way how the website works. So if I am at this domain, so my local IP, this port, I basically should be allowed to only access for the data or for the scripts for any data like files, etc., from the same domain and port. So meaning that I should only use the stuff that I own and not use anything that other people own. And that's exactly what happened after some time, and it solved the problem of those pesky hackers trying to steal stuff just by embedding scripts on our website, and us by doing some wrong stuff, breaking other people's websites. So kind of it solved the problem, but it was a major limitation. And after the internet community agreed to apply this policy, this is what we end up seeing. Basically, if I'm using the same protocol, the same origin, in the same subdomain, and on the same port, I'm allowed to request for files, data, etc., etc. But in the case I'm trying to access a different port, and the port is where my application works, or maybe I'm trying to access a different protocol, or maybe subdomain is not allowed, or like host is basically not allowed, and I have an exact match. So anything that seems to be malicious is not permitted. And I was actually the thing that kind of solved the whole phishing stuff. So if you work in a corporate environment, you sometimes receive the phishing emails that might have a different URL containing some of the strange symbols, maybe different ports, etc., etc. So that was the whole thing why we implemented this policy. And it was not implemented on every client's machine. So because we didn't have access to it, we needed a way for every machine at the same time work in this way. So the same origin policy was applied at the browser level. So in the case of a typical user, in the case of a typical browser that received that same origin policy update, the browser started to internally reject everything that is not permitted by this origin policy. And that was okay for a typical user that just browses the internet and uses this stuff on the internet that they intended to. So I want to see the weather here, or maybe somewhere I have a form and I want to fill the form and send the data to those developers, those people who maintain the site. That was like a typical behavior. But for us developers, that was a major pain. And again, after some time, we as developers came up with a solution. That's just for your information. It's not that you are going to use it in any way. It's called a JSONP. And it basically is just a piece of or approach of passing some of the data into the resources themselves, because JavaScript is a major source of malicious code, and same origin policy permits only JavaScript communication from the same origin. JSONP is actually about the resources. It's not about executing the JavaScript. It's about getting the files, for example, HTML or CSS from different sources. So JSONP was the approach that we used to bypass the whole thing, and it looks like this. So you specified some of the parameters that you want to send, then you specify the actual method that should be executed, and then this is how you send it. You basically append a special query parameter to the link of the source file in the different origin domain, and that's how you get the method executed on your first domain. Just for your information, be aware that the same origin is a very strict one. It permits just certain things on the web, but we end up overcoming it. But then again, same origin, because of how limiting it was, we needed some time to adopt everything to it. We noticed that developers were trying to solve the whole thing because it was limiting enough. And since those pesky hackers could be just typical developers who are trying to do their job, we needed a way to actually allow some of this stuff to happen. So same origin, it just permits to execute the code on the same origin, meaning on the origin I own. But what if I want to make requests to a different origin? So what if I want to make requests to an origin that I don't own? As in our case, this is Open Weather API origin. And I want to receive some of the data to make my website dynamic. So by applying same origin, I was not permitted that. I could have gone and did the JSONP hacks, but it's not really official. So web community came up with a course, which is a cross-origin resource sharing. And it's a mechanism that the origins and the destination can actually talk to each other and agree to permit some of this stuff even more. So according to course, when my code on my website, this one, tries to make a request to a server, which is an open weather API, browser is the one who initiates that request. Well, after I execute the method to initiate that request, it checks with the server if it's okay to for me to get the data. The server responds with the list of OK websites that or origins that are allowed to make that request. And browser passes that list if my origin is on the list that the server is agreed to work with. It sends the request, receives a response, and that's how I get my data. So that's exactly what happened in our case. So browser just communicated with all this headers, with my stuff that I sent, with the URL, etc., to the server. Server requested that it just really doesn't care who accesses it. So allow origins, and the asterisks here is just saying that all websites are permitted to get that as long as the get and post methods are used, and I used the get method. Browser checked the whole thing, and it allowed communication to happen, and I see my beautiful data displayed here. That's the whole thing about cross-origin. There's a bunch of other implementation at different points in the web life. Lots of different reading if you're interested in this. But the basic understanding is the most important here. Additionally, there is a concept of simple and complex requests. Simple requests are the ones that are done without this weird handshake thing, without the options. Well, the handshake actually happens behind the scene, but it's not the one that we see in the web. So this is a simple one, I believe. Let me check. All this stuff here and by the type. So yeah, as I can see, it's a simple one. So a simple request is the one that is happening without an options request that was sent by the browser automatically. So whenever you make a request and you see that you are actually making a bunch of them, don't freak out. It could be that options request that happens when we make a more complex request that the browser requires additional information from the server. So yeah, we're already seeing how I pass the credentials. It's basically could be in the body itself, or it could be in the URL itself. And yeah, if the origin allows for the full example origin to be, if the server allows for the origin to be a full example server, and that's actually what we're sending it from. So this is the origin. This is how the request looks in the HTTP format. If this origin is allowed, and if I'm using an allowed method, everything would be okay. If not, you will see a nasty error, which is a course error. I can even show you how it looks, because it's actually really not pleasant sight when you're developing web in the web. Error, yeah, this bloody thing. So if you see that, that means that the server is not allowing you this origin that you own to make requests, and you need to access that server if you have access, or you need to comply with other stuff apart from origin, as we see here. One of the examples use the method correctly, use some of the headers correctly. So if you comply with everything on your side, and if it still doesn't work, that means that the server is actually really private and it just don't allow anything outside its own domain to be accessing it. So that's the server. There's also a thing called push notifications. It's you must be familiar with that. It's when the server actually sends the request to all the clients. So instead of organizing the XML HTTP request object, or maybe using some kind of fancy library or in a fetch, the server is actually the one who sends some requests to us with either data, or maybe they get some information from us as an analytics thing. So every time we see some of the push notification happen, that's when we know that one of the types of server events happened. And if we take a look at the types, we have polls, long polling, maybe hidden frames, WebSocket, or event source. So every time we need the server to tell us that something had happened, we have different approaches. So it's not that I want to get the stuff because I know that the stuff is already there. It is for the situation that I don't know if something happened, and I'm waiting for that thing to happen, and I need to update the front end, not on the reload of the page. So every time a new user comes, or maybe a current user reloads the page, but dynamically. What if the user just reads some of the stuff here and the user gets a notification that, hey, your update was processed, here is some info, if you'd like to continue, press some button. So that type of thing. And from the browser perspective, we can do that in a number of ways: polls, long polling, hidden frame, WebSockets, event source. Interesting stuff, but kind of high level and outside of the current discussion. But just to be aware for you to that you can either initiate the request resources yourself, or wait for the resource to be available and the web server or even the browser somehow notify your code about stuff that is happening in the background. So going back to the Ajax, what is Ajax in the end? It is a way for us to implement some of the web actions really fast, and it's a natural and intuitive way for users to interact. So because we, as people who've been using desktop applications, they're kind of used to having all the information displayed already for them, specifically for them. But for the web, since we are actually building a website, a static application, static page, we need some kind of a way for user-friendly logic, and that's how the Ajax actually what its role in the web. We have less or no page refreshes. The extreme case, so the opposite case of an Ajax to the static web page, is a single page application. You've heard of it already. It's when you have an open application, open page that has everything it needs from the first load, and every update it gets with a new Ajax request, and it kind of updates the display. Yeah, and we're separating the displaying of the actual UI from the data fetching. So as in the case of our small website, we're separating the display of the whole thing from the actual data. So we don't care really what goes inside this block. We're just designing and implementing the block to be able to fit any data, maybe with some of the limitation, but actually at some point don't see anything here, and it's just a blank black square. So the cons is like we don't have ability to for users to bookmark the website. what it means is that if I want to share it or maybe store it somewhere, I'm storing just the blank HTML. And next time I'm accessing this, as you see now, when we started the lecture, it was 23 degrees Celsius, and now it's 22 because I updated it and it changed. So if I am to store it, I don't store the actual data, I store just the code that retrieves that data. And then in search engines, if we do lots of requests to filling the whole page, just imagine I'm filling the land in a hotel, I'm filling the image, I'm filling all this stuff with individual, maybe some aggregate requests, and my page is just a small div that doesn't contain anything, and when it arrives to a client, to me, that's the moment where I'm starting to update the page to actually contain at least something. That initial moment, most of the search engines, they don't execute JavaScript, so they don't get all those juicy content stuff, and that means that for them, for any robot of Google or maybe CEO optimization tool, our page is just a blank thing with one div. So by making the whole page dynamic, we are not doing the search engine optimization. We have an inaccurate back and forward button actions, because if we're doing a single page application and if we go back and forth there, the information could be different, or we could have gone in the whole application flow far too long way for the back and forth button to be actually useful, because when I do this, I'm actually requesting the page itself, not the JavaScript logic that we did previously. So if I want to somehow do the back and forth buttons, I'm either implementing it myself or hooking up some logic to the buttons themselves. So there is an extra work that is not present with static websites. So yeah, and that work, it just requires lots of JavaScript code. And at this point, when we introduce the Ajax, we introduce all the ways that the users could interact with our website. That's when the JavaScript was no longer considered just like a scripting language for those, like for people to just animate some stuff on the web. It was actually the point when we started to do some really heavy and complicated logic that made us look cool. So kind of lots of information, but we're still not done, because we have another thing which is called a promise. And before we do the promise thing, I'm going to do a little demo again. So the jQuery was actually trying to solve the XML HTTP requests cumbersome logic, but in a way it was a UI library for UI updates, etc., etc. So the language itself didn't have any ways to do this stuff in a beautiful way. But at some point, all the browsers received a fetch API. And when I say fetch API, I mean, so we have the same logic, I mean that at the high level, so I'm not defining the fetch here, so if we look for the fetch, I'm not defining it anywhere. At the high level, we got the fetch function. So yeah, this is how it looks. Fetch function somewhere. Declaration, I'm not really sure where I am. I'm at the TypeScript. So we got the fetch function that was designed to look similar to the thing that we did with jQuery. So kind of looks the same. So then in the case of error, just do some update here in the catch. So in jQuery, just done and fail. In the fetch case, it's then, and catch. So similar approach. So it was designed in this way because it was really nice to exercise that composition or maybe chaining of methods to describe the logic that should happen. But under the hood, it used some kind of more abstract way of doing asynchronous stuff, not just the requests. And that stuff is called promise. So if you take a look at the end of this description, the fetch returns the promise. And the promise is the thing that actually enabled us to use this beautiful syntax to make requests. So fetch is all about requests. It is internally a promise to do that beautiful stuff. So, but promise is not only about the requests, so just for you to remember. So as you can see, it's almost the same as this one. And if I were to execute it, hopefully I don't break anything during the demo, and it still works. Yeah, it still works. So let's take a look at the actual live data. Yeah, we're making that request again. We're doing the same thing. We're passing the same stuff. And we're receiving the same stuff back. So it does the same thing, but in a more beautiful and natural way. And actually, to make that happen, to use that beautiful syntax, I don't have to install jQuery. So that's what this is all about. But it actually uses the thing called promise, and that's what we're going to discuss now, because promises are all about asynchronous stuff in the JS. And yeah, let's go to the presentation. So what is a promise? A promise, again, as everything in the JavaScript, is a special object. Promise is a special object. It has some of the different properties. It has a state, and it has a pending state, fulfilled state, or rejected state. So just imagine a JavaScript object that has all those fields. The status field and all those values in the status field. So this object could in time become either fulfilled or rejected. Until that, it is in the pending state. So, and we can listen to those events as with the XML HTTP event, we could have hooked up some logic as we did on the ready state change. So for the same logic, promise is the same object as here, but it has onFulfilled and onRejected. So the states that we've seen, so onFulfilled and onRejected, and we can hook up some logic to those events. And this is how it looks. So when I create a promise, I use, again, a constructor function with a new keyword. I'm passing the thing that will be executed when I'm like that is going to do the job of requesting something or doing some asynchronous work. So do a thing, possibly async, and then depending on the outcome of that thing, either resolve the promise or reject the promise. And this function, they come from the actual promise object. So the promise object, when I give the promise object a function, it's called an executor. When I give that executor to the promise passes to executor resolve and reject. And this resolve and this reject is the same stuff under the hood as onFulfilled and onReject. So when I'm done with async stuff, or maybe synchronous stuff, it could be in the same way, I'm either resolving or rejecting the whole thing. And the promise is done. So while it's doing its job, I'm able to continue working with my code with a promise. And then I'm specifying what should be done on every other case, either resolve or reject. So remember the code with the XML HTTP request. that's how it looks with the promise API. So executor is the one that is going to do the async stuff. So that's where we put the XML HTTP request logic. But at some point when we're done with the requests inside that object, we're going to either resolve or reject. So kind of a strange way to do that, but trust me, when we actually utilizing the promises using fetch, that's all done for us. So you can actually think of the fetch as a syntactic sugar on top of the XML HTTP request logic, old stuff that uses the promise API. And that's how it looks. So I want to get the talk.json, and when I'm done, hey, success, or hey, something went wrong. That's it. So instead of actually creating this function HTTP get, as we did here, for our case, we have that fetch API function. That's good to know. So that's not the end. So promise, the actual, what is that? Yeah, the actual thing that is stored in the promise variable is an object. It has those then and catch method that we've seen here. So then, in the case of the fetch, we have also catch. That's all part of the promise API. And without actually going a bit inside of the technical details, you can think of a promise as a like a ticket that you get in a typical, I don't know, restaurant where you order the food, for example, a fast food chain food. You come to the counter, you say, hey, I want some juicy burgers, and when you're done, just bring it to me. Or if it's not available, just say it's not available and return the money. And the stuff inside the actual restaurant says, okay, here is a ticket. When store it, and when you see a number on the screen that says, hey, your stuff is ready, or we're done processing your order, come onto the counter and see if it's fulfilled or rejected. So you can see, think of the promise object, this one, not this one, it's a promise constructor. So the promise object is that order ticket that you have, and you can go around, do your business, and then when the order is actually fulfilled, you go and check if it's successfully fulfilled or if it's not. And you specify what you're going to do in either of the cases using then or using catch. So, and then in the actually specifying, you can actually specify a number of steps that you're going to do. So, as in the real life, when your order is done, you say, take the food, find a place, and maybe even eat the food and leave the place, leave the restaurant. So you have the ability to chain stuff, and it's all out of the box in the Promise API. A more practical example in our case would be, imagine we either do a manual HTTP get, or we're specifying the fetch or using the fetch API. So get the JSON, receive the response, pass the response, because we need to pass to get the actual object, because the JSON is actually a string-like thing, and then do something with it. Hey, yeah, JSON, and display the JSON in the beautiful formatted way. Yeah, and async example again, on top of our JSON thing, we can hide this parsing logic if we don't want to do that. You see that? We can get the JSON again and then say, hey, maybe making another request like here, or and log the user, or maybe catch an error again. So You can return some promises. So as you can see, I'm returning another promise with appended user ID and then handling that user. So that's a very typical thing when I'm, for example, asking for some configuration, get that configuration. So I'm receiving the past version of the configuration. I'm retrieving some of the stuff that I need for the next request. So I'm retrieving the user and immediately making that request and then already working with got the user thing. So just imagine as we are retrieving all the users, and then when we got all the users, in this block, we're passing the users, trying to build some if statements that find or filter the user array to find the necessary user that we want to have some detailed information on. And then we're constructing a promise or like a request for more detailed information for that particular user that we would like to see. And then we work with that user again. So it's like a profile page of your, I don't know, Facebook page or maybe GitHub page would have a similar logic. It will access all the data, it will get your ID and will make another request. And that's a typical way of chaining different requests, one after another, if the second one requires some of the data that is only available in the first one. So you make a request and then you do everything else in the then block. That asynchronous stuff has one problem, and it was around for ages already, which is like error handling and maybe keeping track of all the different errors that we see. Luckily, in the in a promise API, we can rely on the catch block that is going to catch everything that went wrong in the upper block. So without going into much of the details here, because the error handling topic is always the tricky one, especially for the async stuff, just know that it's a good practice to not specify only the then block, which is most interesting for us as developers, but also specifying some of the error handling stuff, which is at least would be console logging the error to see if something went wrong without silently failing or displaying something weird. So you can just imagine that the catch block will contain some of the logic that would hide the data or show the message to the user, as in our case, if we have an error in the application, just don't show the block box to anyone, so that we're not that it's not that awkward for us to show something weird and empty for the users, so we'll not be shamed by anyone because they didn't even see stuff and they don't even know that something went wrong. For example, like this, or maybe some graceful error handling. Promise has some static methods, so promise constructor, promise construct function, maybe class if you'd like, has some static methods. Without actually creating a new instance of that promise constructor, so constructing promise, we can immediately resolve with some of the stuff. So resolve method is available to us. Also reject is also present on this constructor. So imagine I don't need to construct going into a long way of constructing the promise as we did, for example, in the, I think in here, yeah. So I don't want to do that only to get some of the fake data, for example. I want to immediately resolve or reject something. So that's utility methods that are available on the promise constructor, as static versions of them. Another one is all. So if I were to make lots of parallel requests, for example, get all the users, get all the configs, maybe get some of the comments. And they're not really interconnected in between, so I don't need to chain them. I can actually go and request them all at once, but I need to know when they all resolve successfully, when they're done. So when I have 3 of them here, I want to know if they're all successful and, I don't know, show some fireworks on my website. I don't know. That's what is available. So basically this method receives an array of those promises. So promise objects, not the promise constructors, but the actual promises that are already created. And it just keeps track of whether they all succeeded. If one of them fails, the whole thing promised all fails. So if 2 of the requests were successful and only 1 failed, the whole thing will fail. So no fireworks for anyone. We also can introduce a race, and it exactly how it sounds. If I make 2 parallel requests, maybe 2 for similar information, but I want to use only the one that is faster. So a typical use case would be, I want some weather here. It's a simple weather. It should be available in lots of different APIs. I'm making several different calls to different APIs for Open Weather API, maybe some BBC Weather API, some local API, and the fastest that gets back to me with the temperature and the basic description of the current weather is the one that I care for. Everything else could be finished. Is the use case for the promise.race. Also it receives that array of promises, promise objects that are already in flight, so they are already happening, and the race method, it just is just a promise that keeps track of them. Yeah, examples. We're accessing different APIs and we want all of them to get successful results and hook up some logic to that. That's how it looks. It could be used for the caching also, additionally. Prettify the code. Yeah, that's how it looks when we want to maybe organize some logic. So as you can see, we're not just making some requests to some APIs. We can just use any synchronous stuff. But maybe that synchronous stuff either old as set timeout, or maybe we can just abstract, build a layer of abstraction so with synchronous or asynchronous or time-consuming stuff. That's how we can use promise. So really nice API, really useful in most of the cases. And one could say that Promise API was a replacement for the problem that we had with old JavaScript, which is callback hell. So if some of you are familiar with the callback hell, Promise API was partially a solution to the callback hell because it simplified and linearized the logic, because instead of actually passing callback after callback after callback into each other like a Russian doll, I'm actually chaining them together one by one using the then method. And they were introduced in the 2015 standard. They're now like everywhere. Before that, we had some promise-like libraries because the idea was around for several years already. We had some promise-like libraries that implemented the same syntax at least, but it was not officially a part of the language. So it was a dependency for us, which is not that good. Different libraries had problem with compatibility, so be aware of that if you're going to be part of some kind of legacy project. But I doubt that some of the project now are going to be using something different from the promises at this point. And yeah, as we talked already, Fetch API is the one that is using promises, so then catch, instead of awkward syntax that we have with XML HTTP requests object. As a bunch of use cases, very easily Googled ones. One thing to be aware of is that the response body is a stream under the hood. So that means if I'm using special kind of syntax, so if I'm using this, that means I read the stream and I don't have the access to the live data already. So I consume the stream and I can just work with the result of that consumption, not with the actual stream itself. That's one of the things to remember, is that careful with the response body consumption. You cannot read the same body twice. You can just consume it once. And there are methods that are consuming that response body. It's like, let's just say we have one barrel of wine and has that pipe that sticks out of the side of the barrel, and you can actually drink the barrel once before refilling it. So if you already used it, it's already partially empty, so you need to make another request for another barrel of wine to then consume it. So be aware of the consumption thing. So, and yeah, it's true for all the stream readers. So for all of those functions that simplify the reading process for you, as we saw with the string that is returned in place of the JSON, and we actually need to turn that string thing into the actual data that we can use in the JavaScript. As a workaround, we can use the cloning. So we actually cloning the stream into local variable, either manually or using some of the code, and then we can read as much as we like. You can have a further reading on that, but I think it's pretty straightforward. And I am done actually with the lecture. So do you have any questions regarding the stuff that we discussed today? It was a huge lecture, actually. Okay, I assume that it is too much information to consume all at once. Just quick, like, tip for you when you're gonna do some of the requests in your project, any of the starting project, just use Fetch API. That'll be much easier instead of constructing the XML HTTP logic, because it's kind of outdated already. And by using Fetch API, you're not just completing some of the async stuff on your website, you're either training yourself to and preparing yourself to use Promise API, which is a really beautiful thing, and it enables us to do lots of cool things. Yeah, I believe you need some time to understand. Yeah, sure. So yeah, if you have any questions, feel free to use this chat later. But for now, I'm done with the lecture. Thank you for your attention, and see you guys next time.
Dimas, thank you for lecture.
Thanks. You're welcome.